Hi, everybody. We're going to continue with the PSAT section that I started. This is numbers 31 through 38. These are the last bunch. So take a look at this one. It says that we have four variables, A, C, G, and K are integers, and they have to follow this order. These are ordered in order. So 0 is less than A, is less than C, is less than 6, and so on. We want the least possible value for A plus K. So what I'm going to do is I'm going to pick the least possible value for A and the least possible value I can have for K. Notice that they cannot be equal to each other. So try it yourself, pick the least possible value, and then add A and K. So for 0 less than A, it means it has to be 1. C can be anywhere in there, but I'm going to go ahead and go with the least possible value for C. 6, I want the least possible value for G, which has to be an integer, so it's 7. And K has to be 8. So the least possible value for K was 8. The least possible value for A was 1. And I have A plus K. The least possible value is 9. And we're moving on. I can be absolutely sure on this one. These are in order, so a couple of things you got to think about is that they have to be integers and that they can't be equal. Anyway, this is a triangle problem. It looks like the three sides are different. This is just a copy mistake, so it isn't. There's no marks on it. In the figure above, RS equals ST. Oh, RS does equal ST. Those marks do matter. So obviously X and Z are equal. That's because isosceles triangles have equal bases. And it says that X equals 30. What is the value of Y? So solve it. And hopefully you got it. And you put the 30 here. And of course the 30 here. And the sum of these three angles is 180. So we're looking at 120. If I were going to do the work, I would say that X plus Z plus Y equals 180. And since these are equal, it means this is 30 and 30. I'm going to subtract the 60 from both sides, and that's where it came from. That's the work I would expect for most students would need to do this. Anyway, moving on. In a biology class of S students, there are M microscopes available. If the instructor assigns 1 microscope to each student, 6 more microscopes will be needed. So what this says is that there are more students than microscopes. And in fact, there are exactly plus 6. We need 6 more microscopes for the microscopes to equal the students. However you want to think of it, but that makes the most sense. That's what that first sentence says. If the instructor had twice as many microscopes available, and assigned 1 microscope to each student, so this time he has 2M available, and assigned 1 microscope to each student, 6 microscopes would be left over. This time it's 6 extra, so it's going to be S plus 6. There would be the number of students, plus we would have 6 left over. A little tricky on how to set those up, but once you have the equations set up, you could find S. You can use substitution, lots of ways to go, and I'm going to do that. I could solve for M by substituting this one in, like this, or I could do it more directly and solve this one for S. No, I'm just going to do it this way. 2M equals M plus 6 plus 6. So subtract the M, and I have M equals 12. And that's 6 plus 6 is 12. Sorry, M equals 12. And it says, what is the value of S? Well, 12 plus 6 is 18. Now, what I would do, if I had time, I would go back and I would double check this answer. I'm pretty sure, so I would put a 18 and I would put maybe a check on it. I'm going to go back and double check it. All right, number 34. What is one value of X for which this is negative. Okay, so we want this thing to be negative. Now, x can be anything at all, but we want it to be negative. Now, if both of these end up being negative, in other words, if I pick a number like 1 or 0, then this is going to be a positive because I'll have a negative times a negative. If I pick a number too big, it's going to make them both positive. For example, if I picked 5, it would make it positive. So think about a number you're going to choose, put it in. I'm pausing for a second to do for the Ed puzzle. So I'm going to pick 3 just as an example. This 3 will make this piece positive over here, and it'll make this piece negative. So 3 is an answer. I could pick any decimal that is between 2.73 and 3.45. Now it can't be equal to these because then I'd get 0. But anything in between there would work. Any number at all. Actually, you know what? I'm not going to pick 3. I am going to pick 3.15 to be just weird about the whole thing. You can pick any number in between, and I recommend that you choose a different number. Don't pick 3. That's too obvious. Pick a different number in between there. Okay. And I am absolutely sure on that one. Let's see how we're doing. Not doing too good for time. I better hurry up. Okay. What do we got? We have the average, called the arithmetic mean, of all these numbers is 120. There are 1, 2, 3, 4, 5 numbers there. Well, something you need to know about averages is that if you add them all together, t plus u plus v plus w plus x, we add them all together, we divide by 5, we get the 120, which is the average. What you want to remember is that the SAT is going to test you a lot on knowing that if you multiply by 5 on both sides, the sum of all these is 600. A lot of times the question will ask something about that. Now, if the average of these numbers is 80, so everything except the x adds up to 80. So t plus u plus v plus w divided by 4 equals 80. Now remember, you have to divide by 4 to get the 80. Now this time, I am going to get what these numbers equal. So do that. T plus u plus v plus w. I'm going to multiply by 4. And I'm going to get 320. And look what happens if I subtract these two. That's how you find what the value of x is. Let's see. 600, because this total includes the x. This could be substituted if you want to think of it that way. They put the 320 there and then subtract the 320 from both sides. You'll see they tested this very well. Well and thoroughly. They tested to see if you understood that the sum is the average times the number of parts. Anyway, there it is. Finish it yourself. Number 36. We have to know about exponents as well. Now, this means that I multiplied an extra x here, because when you take x to the a times an x, sorry, this is an a here. It's not very clear. This is supposed to be an a. Let me try it a little bigger. There we go. It's equal to x to the a plus 1, because I add the exponents. Anyway, that's supposed to be an a. It keeps looking like a 9. There we go. So this is something that's true. And if I divide by x to the a on both sides, notice what happens. These cancel out, and I just get an x. X equals x, in other words. So it says kx to the a equals x to the a plus 1. Okay, in the equation above, x, k, and a are positive integers bigger than 1. What is the value of k minus x? Well, if I take k, well, let me put it over here, kx to the a, and it's equal to x to the a plus 1. I told you what to do over here. Think about it, and what you're going to get is, let me get rid of this for a second, k equals x. And of course, that gives you the answer of what you're going to get. think about it and figure it out. I'm not going to write the answer because it's just too easy. K is equal to X. Think about Y. For number 37, how many 3-digit positive integers have only odd integers as digits? Wow, I'm going to count them. So I have 3 digits. So I have the digits could be, let's see, no zeros, because zeros is the beginning, have only odd digits. So it would have to be 1, 1, 1. And the very next one would be, it has to be all odd digits. 1, 1, 3, and then 1, 1, 5, and so on, all the way up to 9, 9, 9. Now, to get a number of things, we multiply choices. And what you want to think about is how many choices you have for these with just starting with ones. So 1, 1, 7, and 1, 1, 9. These are my 1 ones. Now that means I have 1, 2, 3, 4, 5 choices for this place over here. And for this middle place, I have 5 choices. And for this first one, I have 5 choices. So I'm going to guess that if I multiply my choices together, I am going to have 125 pieces all together. And it's about choices. You're multiplying choices to get the number. If I had just said how many 3-digit positive integers there are, it would just simply be 10 times 10 times 10. There's 1,000 of them. They go from 000 to 999. Anyway, there it is. Hopefully it makes sense to you why I can only have these odd numbers. I can only choose odd numbers. And moving on. Last one. Number 38. A wheel made, I love this. This is probably the kind of problem you're going to run across in physics doing dimensional analysis. So 3,000 revolutions while traveling 45,000 pi inches in a straight line along the ground. What is the radius in inches of the wheel? Well, remember that circumference equals pi diameters, or 2 r's. So this is 2 pi r's, the way most people write it. So the circumference is 45,000 pi, and it says 3,000 revolutions. One revolution would be 1/3,000th of this. Oh, sorry, 45,000 I said. 45,000 over 3,000. That's going to give you your circumference. And once you have that, you'll be able to find your radius. And this is in inches of the wheel. And I'll set it up the rest of the way. This is equal to 2 pi r. In order to get r by itself, I'm going to simplify this side. That's going to be 9,000 pi. And that's 2 pi r. And I'm going to divide by 2 pi on both sides. And I am not going to give you the answer. You'll have to figure it out yourself. And that is going to be the radius of the wheel in inches. Did I get that? I did not. This is, geez, I'm dumb. 3,000 divided by, this is not 9,000. What am I doing? That's 15 pi. Sorry, guys. Can't divide today. I don't know what the heck I was doing with that. Anyway, 45,000 divided by 3,000 is 15. And I get 15 pi is equal to 2 pi r. And I'm going to divide by the 2 pi and get the answer of the radius in inches of the wheel. And I said I was going to go back to that one about the microscopes and double check it. Let's take a look at it just one last time. If there are 18 students in class, there are M microscopes, and presumably there's 6 that we need extra, so there's 12 microscopes. If we double the number of microscopes, which would be 24, do we have 6 left over when we hand them all out? We do. I am absolutely sure on that one, and I'm moving on. Anyway, I hope you guys got some of them and do a good job on your SAT. Bye, guys.